talking, I said, oh, I'll wait for you. How's everything going?
We're finished up the last senior design group through there. And we got the
Yep. I think it's going to be a lot of fun.
What I got to test.
Please show us your working prototype. Down and explain how it works.
Well, unfortunately, my teammate a laptop and controller had it. The basic idea is we could have a computer here, it's just throwing another microcontroller here. The method that we were using was method one right here. We did two methods where microcontroller one, the one with the radio frequency transmitter, which would be this one right here, would send a synchronizing ping from this transmitter to be picked up by this receiver over here, which would then be recognized by the microcontroller, which would transmit a signal to the ultrasound transmitter, which would send an ultrasonic ping of 40 kilohertz to the receiver here, which would then pick it up, demodulate it, and send it to this microcontroller here to be received. And that's basically the layout which you see here. Here's a graphical representation. Is that at time 1, the ping is sent, and then microcontroller 2 picks it up at time 2, and from which it signals the ultrasound transmitter to send the ultrasound, that's T3, after some delay. That delay is usually constant, it can be measured. And then it takes the time of flight for that ping to travel to the other microcontroller to the receiver, that's T4, is the time that it takes for the microcontroller to recognize it. And then it takes this distance minus this distance, and that'll give the total time it took. And then it subtracts from that the time it took for the ultrasound to be sent and the average synchronization time for the average time it takes for the ping, the original ping to reach the microcontroller, and that'll give us the time of flight and how long the ultrasonic ping has been sent, and then we multiply that by the speed of sound to give us the distance. Well, there are various methods of synchronizing microcontrollers like this. I like to make usually much more expensive. Our goal for this was for him to replicate the master on his project, which would eventually have been turned into an ultrasonic positioning system, which he was aiming for sub-millimeter accuracy, tracking an object in 3D very accurate precision. So that's what our project was. As far as there's things like that, there's different systems that can do similar things.
You take like a second like bacon.
So what did
That's honestly, that's a pretty good question. This it's basically our way of synchronizing the life methods. There's so many different ones out there. And this was being specifically made for different applications, so we don't know if there's exactly basically for UTDesign 1, we were still just testing various chips and computers as transceivers and receivers. And so from what we did from that was we built an ultrasound system to receive the forces and recognize them. We got the microcontroller up and running a program to recognize the pings being sent. And that calculate the distance between the two. So basically, we're looking at what we did have to take the methods of producing the radius.
I'm assuming that. Excellent. Keep thinking of the future. What future changes or possibilities arise for this project?
Well, looking forward, what we would want to do is we would move towards more something like an ultrasound position system. We want to obviously change the transmitter and receivers, the radio frequency transmitter and receivers to get them more accurate and more quickly recognizing the signals that are being sent. We would also want to change the ultrasound so that it's far more consistent now, so that we can take those values, the alpha and the beta can be more consistent, basically the delays will be more consistent so that we can take into account further to reduce our error and distance variance. There's also other methods by which we can recognize the transmitter that would further reduce the synchronization rate. So basically we would change the recognize the synchronization, we would change our hardware to be more sensitive and more accurate so that we can